In this video, let's go ahead and apply our understanding of implicit differentiation to find the second derivative of a particular equation together. To get the most out of this video, I encourage you to grab some paper, something to write with, and let's do some math together. Let's start by just copying down the original equation together. Alright, so here's the original equation, and we know we're going to be taking the second derivative of this equation because we have this y double prime here. As we get started, don't let that intimidate you too much. Let's just go ahead and find the first derivative first. So if we go ahead and do that on the left side of the equation, it's going to look something like this. And then if we go ahead and do it on the right side of the equation, it's going to look something like this. Now if you go ahead and take the derivative of each of these terms, on the left side the derivative of this x squared is just going to be 2x. Let's go ahead and write 2x down here. And then if we go ahead and take the derivative of this next term, next if we take the derivative of this 4y to the second power, we can go ahead and apply the power rule and bring that 2 down in front, so 2 times 4 is going to be 8. It's going to be 8y to the first power, or just 8y. And then don't forget, when you take the derivative of a y term, you have to multiply that by dy dx, but for shorthand I'm just going ahead and write y prime here, which is going to be that dy dx. And on the right side of the equation, we have the derivative of 4, which is just a constant. And remember, the derivative of a constant is always just going to equal 0. So we're going to set this equal to 0. Now let's just go ahead and clean this up a little bit by dividing everything by 2. If we go ahead and do that, we're going to be left with this x plus 4y and then multiplied by y prime, or dy dx. That's going to be equal to 0, since 0 divided by 2 is still going to be 0. Now to find dy dx, or the derivative, let's go ahead and isolate this y prime here. We can go ahead and do that by first subtracting x from both sides of the equation. If we go ahead and do that, we're going to have 4y times this y prime, and that's going to be equal to negative x if we subtract the x to the other side. Next, let's go ahead and just divide both sides by 4y. If we go ahead and do that, we're going to get y prime is going to be equal to the negative x on the other side over this 4y. So that's going to be what y prime is equal to. And so writing this out pretty clearly, we know that y prime, or also known as dy dx, is going to be equal to this. And it's up to you where you want to put the negative. I'm going to put it in the middle here. It's going to be negative x over this 4y. Now this isn't our final answer. Keep in mind that this is just y prime, or the first derivative. We can go ahead and use this to then find the second derivative of this equation. And so let's go ahead and continue on to find the second derivative now, or y double prime. And so let's go ahead and just start by writing the original equation here and say we have y prime is equal to this negative x over 4y. This is going to be kind of like our original equation, I guess you could say. And what we're going to do here is to find y double prime. Let's go ahead and differentiate both sides of this equation in respect to x. And so to find y double prime, let's find d dx of both sides of this equation. So let's go ahead and find d dx of this y prime on the left side of the equation. And on the right side of the equation, let's go ahead and find d dx of this negative x over 4y. So let's go ahead and apply that to both sides of this equation. Now on the left side of this equation, if you go ahead and take d dx of this y prime, we're really just finding out the second derivative of that. So that's just going to be y double prime. So we're just going to write it as y double prime for now. And on the right side of the equation, let's go ahead and see what we're dealing with. You want to be a little bit more careful with this piece over here just because we have a quotient. So let's go ahead and write this on the side to be extra clear, because this can be a little bit confusing. I'm going to move the negative out in front just because we don't have to deal with that negative if we don't want to. So it's going to be the negative d dx of this x over this 4y. Okay, so let's go ahead and just look at the quotient rule for this x over 4y then, and we'll apply the negative on after. Alright, so how does our quotient rule work again? Well, first we're going to go ahead and take the denominator here of 4y, and we're going to go ahead and multiply that by the derivative of the numerator. So we have this 4y multiplied by the derivative of x is just going to be 1. So I'm just going to say it's going to be 1 here. Now that we have the denominator multiplied by the derivative of the numerator, let's go ahead and find the difference of that with the numerator, which is x, multiplied by the derivative of the denominator. Now, the derivative of 4y is going to be 4 dy dx, or 4y prime, all right? But just remember, if you take the derivative of anything with a y in it, we have to have that dy dx, or y prime for short. And then don't forget, when we're dealing with the quotient rule, in the denominator, we're going to have the denominator squared. So if you go ahead and square 4y, that's going to be 16y to the second power. All right, let's clean this up a little bit. So we have this 4y times 1. We can just say that's going to be 4y, right? And then let's see what else we have here. So then after that, we have this x multiplied by 4y prime. So I'm just going to say that's going to be minus 4xy prime. And this is all going to be on top of 16y to the second power. So nothing to do there. Now notice how all of these terms has a 4 in common, so let's go ahead and divide everything by 4. If we go ahead and do so, we're going to have y minus this xy prime all over this 4y to the second power. I'm actually going to go ahead and just take this y double prime and move it down a little bit just to get some more space. And so this thing right over here is going to be the derivative of this x over 4y using the quotient rule. Now keep in mind that we ignored this negative a little bit earlier. We put it in front, so let's not forget about that, right? So we can say that this y double prime is going to be equal to this negative, and then we have this y minus x times y prime is going to be all over this 4y to the second power. Okay, so this would be our derivative of the right side of the equation. All right, so now notice this y prime real quick. And from earlier, we knew that y prime was equal to this negative x over 4y. So if we go ahead and make a substitution here, we can say that this y double prime is going to be equal to this negative, and then I'll take this y on top here, y minus this x multiplied by y prime, but we know y prime is going to be equal to, and then substitute in, it's going to be negative x over 4y. And we'll take that whole thing and put it over this 4y to the second power. All right, so let's go ahead and clean this up a little bit. So we have y double prime is equal to y, and it's going to be minus a negative x squared, or we can say it's going to be y plus, we can write x squared over 4y. And this is going to be over this 4y squared. All right, and don't forget that negative that we have in front there. So at this point, all the calculus is kind of done. We just have to clean this up using our knowledge from Algebra 2 and pre-calc dealing with some complex fractions. So if we go ahead and just take a look at the numerator here, we need common denominator. So I'm going to multiply this y by 4y over 4y, so we get common denominators over here. So if we go ahead and do that, we're going to have this negative in front. So y times 4y is going to be 4y squared. And then it's going to be plus x squared, right? Because once we do that, they're both going to have that common denominator of 4y. So I'm going to go ahead and write it just like one fraction here. And this is all going to be on top of this 4y to the second power. So now these both have the same denominator, so we just kind of rewrote the numerator as one fraction. Okay, now instead of this fraction bar here, I'm just going ahead and write it as division. So I'm going to say this is going to be, I'll write a negative, and then I'll do what? 4y squared plus x squared. This is all going to be over 4y. And so this is going to be divided by 4y squared over 1. Okay, so just keep in mind that this fraction bar means we're dividing by 4y squared. So I'm just writing it as a division sign instead, but same idea here. All right. When we divide fractions, remember we can multiply by the reciprocal, so we have y double prime is going to be equal to this negative 4y squared. I'm going to try to write everything out as neatly as I can. It's a little, lot of steps here. All over this 4y, and multiply by 1 over this 4y to the second power. Now when you multiply fractions, we can just multiply the tops with the tops and the bottom with the bottom. The numerator is going to be just the same. I'm going to go ahead and write the x squared first. We have x squared plus this 4y squared. And then in the denominator, we have 4y times 4y squared. That's going to be 16y to the third power. Now, this is a pretty good spot to be in. All we have to really do next is take a look at the variables here. We have a y, we have another y, and then we kind of have this x hanging out here. So if you take a look at this x squared, maybe we can rewrite this in terms of y, so we only have one variable, right? So let's look at our original equation here. Let's check that out. We have this x squared plus 4y squared is equal to 4. So let me go ahead and write this out and see if you can tell where I'm going with this. If we take this x squared plus this 4y squared is equal to 4, you could go ahead and isolate that x squared by taking away 4y squared from both sides and say x squared is equal to 4 minus the 4y to the second power, right? So let's go ahead and make this substitution and say, well, if we know x is equal to this 4 minus 4y squared, let's substitute that in here so we only have y's in our y double prime here. So, oh, and don't forget we have this minus sign or this negative out in front, right? So we go ahead and carry that negative over here. If we go ahead and make that substitution, we have this 4 minus the 4y squared. Again, that's a substitution from the original equation. And then we have this plus 4y squared. And this is going to be all over 16y to the third power. All right, so we're almost done cleaning this up, but this negative 4y squared is nicely canceling out with this positive 4y squared. So I think all we have here is y double prime is going to be equal to a negative 4 over 16y to the third power, right? Now we go ahead and divide top and bottom by 4 here. We're going to say that we have negative 1 over 4y cubed. And this is a lot cleaner looking than what we had before. So just kind of cleanly putting this on the side a little bit, I'm going to say that this y double prime here is equal to negative 1 over 4y cubed. This right here would be y double prime of that original equation. And just in case it helps keep things a little bit more organized from earlier, these expressions were all equivalent, as well as these ones. So there you have an example of how to find the second derivative of a particular equation. If you found the video helpful, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep with the great work that you're already doing.